Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum little kids. This is Shehroz Abdullah and today we are going to discuss chapter number 1, class 9th, physics. Chapter number 1, physical quantities and measurements and the numerical problems of this chapter. Okay, if you remember in the previous lecture we have discussed what were significant figures and how to round off the certain numbers. This was previous lecture. In the previous lecture we have discussed how to round off certain number. We have discussed significant figures. We have discussed different rules of significant figures, right? So this was all the things that we have done earlier. Now in today's lecture we are going to discuss how to solve numerical problems and the statement of, let me read the statement of the first numerical of chapter number 1. Okay, what does it says? It says write the number in prefix to power of 10. First part is mechanical nano oscillators can detect the mass change as small as 10 to the power minus 21 kilogram. Okay, mass is how much? Mass is 10 power minus 21 kilograms. Done ho gaya? What is required? Required thing is to write this number in prefix form. To write this number in what? In prefix form. Let me write m is equal to 10 power minus 21 kilogram. I can write this 10 power minus 21 kilogram as 10 power minus 18 multiplied by 10 power minus 3. 10 power minus 18 will be as it is. This 10 power minus 3 will be as it is. Instead of this kilo, I will write 10 power 3. We know that kilo stands for 10 power 3. Okay, now next 10 power minus 18 will be as it is. 10 power minus 3 and plus 3 will combine, as we know that when bases are same then powers are added. Okay, so minus 3 and plus 3 will be combined. They will both finish each other. 10 power minus 18 will be as it is. And this will give you 10 power 0 grams. As we know that something power 0 is equal to 1. Okay, so instead of 10 power 0 I will write 1. Okay, when 1 is multiplied with 10 power 18, again we get m is equal to 10 power 18 gram. And we know that atto is that prefix which stands for 10 power 18. Okay, so the given mass can be expressed in prefix form as m is equal to atto grams. Okay, now what is part B? It says the nearest neutron star collapsed star made primarily of neutron is about 3 into 10 to the power 18 meters away from the earth. Distance is given to you. Now what is distance in the given statement? 3 cross 10 to the power 18 meters. This is distance. Okay, what is required over here? Write the given distance in prefix form. Okay, 3 into 10 to the power 18 meters. We know that exa is that prefix which stands for 10 power 18. So 3 into 3.00 instead of 10 power 18 we will write exa and meter as it is. So this was part number B. Okay, this was what? This was part number B. Come to part number C. What does it say? It says earth to sun distance is 149.6 million kilometers. What is given in the third part? Distance is given 149.6 million kilometers. What is required? To write this number in prefix form. Okay, so how we do? Look, d is equal to 149.6 million kilometers. Okay, and d is equal to 1.49.6 into 10 to the power 6. We know that million stands for 10 power 6. Instead of this million I will write what? 10 power 6 over here. So next we are going to get d is equal to 149.6 into 10 to the power 6. Instead of this kilo I will write 10 power 3. Okay, we know that when bases are same then powers will be added. So we can write that d is equal to 149.6 into 10 to the power 9 meters, and giga is that prefix which stands for 10 power 9. So instead of this 10 power 9 over here we will write giga. Okay, so distance will be d is equal to 149.6 giga meters. Done ho gaya? This was all about first numerical problem. Okay, what we are going to discuss in question number 2. Let me read the statement of question number 2. What does it says? It says an angstrom is a unit of length. Done ho gaya? And which is commonly used in atomic physics, right? And it is an order of 10 power minus 10 meters. means it is given in the statement that 1 angstrom is equal to 10 power minus 10 meters. So let me write the given 1 angstrom is equal to 10 power minus 10 meters. Okay, now what is required? There are 3 parts in this question. It says how many nanometers are there in 1 angstrom? The first part. How many nanometers are there in 1 angstrom? To find the nanometers in 1 angstrom, this is required, the part 1. Okay, part A. As we know that 1 angstrom is equal to 10 power minus 10 meter, done ho gaya. Okay, 1 angstrom, I can write this 10 power minus 10 as 10 power minus 1 multiplied by 10 power minus 9. Done ho gaya. Okay, this 10 power minus 1 will be as it is. Instead of this 10 power minus 9, I will write what? Nano. Okay, so 10 power minus 1, this nano will be written as nm. N stands for nano. Okay. Now this 10 power minus 1 will be reciprocal over here, like I can write it 1 over 10 over here, and 1 over 10 will give you 0.1 nanometers. So we can say that 1 angstrom is equal to 0.1 nanometers. Done ho gaya? Okay, what is in the part number B? In part number B it says how many femtometers or Fermi's, the common unit of length in nuclear physics, are in 1 angstrom. Like in 1 angstrom, how many femtometers are there? Okay, now what is given? 1 angstrom is equal to 10 power minus 10 meters. This is given. To find Fermi's in 1 angstrom. Done. Okay, let me convert this 1 angstrom into Fermi's meter or femtometer. We know that 1 angstrom is equal to 10 power minus 10 meters. Done ho gaya. 1 angstrom is equal to 10 power minus 10. Okay, now I can write over here 10 power minus 5 multiplied by 10 power plus 5. Okay, now this 10 power minus 10 and minus 5 will convert to 10 power minus 15. Okay, and this 10 power 5 I will write earlier or in front of it. 10 power 5 will be as it is, and this 10 power minus 15, we know that it stands for F for femto. So we can write that 1 angstrom is equal to 10 power 5 femtometers. Done ho gaya. Okay, now coming towards how many angstroms are there in 1 meter? This is the third part. This is the part number C. How many angstroms are there in 1 meter? Okay, they are asking how many angstroms are there in 1 meter, or in 1 meter how many angstroms are there? Okay, now look, what is given? 1 angstrom is equal to 10 power minus 10. We have a knowledge about that. To find the number of angstrom in what? In 1 meters. Done ho gaya. Okay, now 1 angstrom is equal to 10 power minus 10 meters. Okay, dividing both hand side by 10 power minus 10. We divide it on left side as well, on right side as well. On left side, both 10 power minus 10 will be cancelled out. What will be remaining? 1 meter will be remaining on the right side. While on left side, what happened? When you divide this left side by 10 power minus 10, let me shift this 10 power minus 10 upward. When it will be shifted, the power will be positive. So 10 power 10 is angstrom is equal to 1 meter. Or we can say that 1 meter is equal to 10 power 10 angstrom, right? This was part number C. Now coming towards question number 3. What does this says? Let me read the statement. The speed of light is c is equal to 299,792,458 meters per second. What is required then? Number 1, write this value in scientific notation. Let me write. Look, given is this speed of light value. Write the value in scientific notation. How to write this value in scientific notation? Look, over here if you see, over here the dot is unseenable in the question. Means dot is laying at the end. We are shifting this dot from right hand side. This is decimal place. Okay, we are shifting this dot from right hand side towards decimal place. Positive power will be used. We have discussed in scientific notation already. So this number will turn to 2.99752458 into 10 to the power 8 meters per second. Okay. Now what is in part number B of question 3? Express the speed of light, number 1, in 5 significant figures, then in 3 significant figures. Okay, how to do? Look, in part B they are saying that express in 5 significant figures. Now the same quantity which we have written in the first part, just write 5 significant figures over there. Like write the 5 numbers and leave the rest numbers. So the value will turn to 2.9975 into 10 to the power 8 meters per second. Okay, now part C, writing the same number in 3 significant figures. Just write 3 numbers, leave the rest. 2.99 into 10 to the power 8 meters per second. So this will be right answer. Done ho gaya. Okay, coming towards question number 4. What does it says in question 4? Express the following in terms of power of 10, right? What they are saying that you have to express the given quantities in power of 10. Look, they say 7 nanometers. 7 will be as it is. Instead of nano, we will write 10 power minus 9. Then meters as it is. Okay, then they say 96 megawatt. In 96 megawatt, what we do? We write 96 and instead of mega, we will write 10 power 6 watt. Okay, coming to part number 3, 2 gigabyte. 2 will be as it is. Instead of giga, I will write 10 power 9 bytes. Okay, then 42 picofarad. 42 will be as it, 43 will be as it is. Pico, instead of pico, we will write 10 power minus 12 farads. And then 2 millimeters, 2 will be as it is. Instead of this milli, I will write 10 power minus 3 meters. Okay, this was all about question number 4. Now coming back to question number 5, what does it say? Let me read the statement. They are saying, write the following numbers in standard form. There are two things. The first is mass of bacteria cell, and it is given that 0.00000000005 kilograms. Okay, how to convert this number into scientific form? It's quite easier. Look over here, the decimal place is after 5 and the dot is laying on the left side. We are shifting the dot from left hand side. Minus sign will be used. Okay, we will write 5 into 10 power minus. Okay, how many digits we have crossed? Look, 1 2 3 4 5 6 7 8 9 10 11 12 12 digits we have crossed. So we will write 5 into 10 power minus 12 kilograms. Done ho gaya into scientific form. Over here the dot is laying at the end and the decimal place is between 1 and 3. So we are actually bringing the dot from right hand side towards decimal place. So I will write 1.39 into 10 raised to the power. Plus sign will be used. Why? Because we are shifting the dot from right hand side towards the decimal place. Okay, now how many digits you have crossed? We have crossed 1 2 3 4 5 6 7 8 9 digits. So we will write 1.39 into 10 to the power 9 meters. So this one, in today's lecture we are going to discuss the MCQs with their solution manuals. Like MCQs with their solution manuals. Solution manual mean how to solve a certain MCQs, right? Okay, so we are going to discuss all one by one. Let me read the statement first. In the first MCQs it says, how many millimeters are there in 10 centimeters? Like how many millimeters are there in 10 centimeters? Do remember one thing, the right option is of MCQs 1 is option number A, which is 100 millimeters. Question is, how many millimeters are there in 10 centimeter? Question is, how many millimeters are there in 10 centimeters? So right option is 100 millimeters. Now let's understand how this 100 millimeter comes. Now this is the solution manual of MCQs number 1. Okay, now look, 10 centimeter we are converting into millimeters. Okay, let me write 10 centimeter. Okay, 10 is as it is. Instead of this centi, I will write 10 power minus 2 because centi prefix stands for 10 power minus 2. Okay, instead of this centi, I will write 10 power minus 2 and meter as it is. Okay, and 10 power 1 or just 10 and 10 power minus 2 will give you 10 power minus 1 because we know that when bases are same then powers are added. I can write 1 at the top as well. Okay, 10 power 1 multiplied by 10 power minus 2 will give you 10 power minus 1 meters. Now what we do, I can write this 10 power minus 1 as 1 over 10 also, 1 over 10 meter also. Okay, we know that in 1 meter there are 1000 millimeters. There are 1000 millimeters in 1 meter. So instead of this m, I will write just 1000 over here and 1 over 10 will be as it is. 1 0 of this 10 and 1 0 of this 1000 will be cancelled out. When you multiply 1 with this 100, you are going to get 100 millimeters. So what we have concluded, in 10 centimeter there are how much millimeters? 100 millimeters. Done ho gaya? So this was MCQs number 1. Okay, let me read the MCQs number 2. What does it says? Which of the following quantity can be measured by using a micrometer? Micrometer means they are talking about micrometer screw gauge. So option number C is the right answer of this MCQs, which is length. Length can be used by very accurately by using micrometer, screw gauge. Okay, come to MCQs number 3. Let me read this statement. The instrument best measures the internal diameter of a pipe. 4 options are given. Best option or right option over here is option number B, which is vernier calipers. Okay, now come towards MCQs number 4. Which prefix represents a largest value? 4 options are given. Right option is D, last option, which is exa. We know that 10 raised to the power 18 is prefix which is used for exa over here, so it shows you the largest value over here. Done ho gaya? Okay, in MCQs 5, what does it says? Which of the following is smallest prefix? Like 4 options are given to you. The right option of 5th MCQs is option number A, which is atto, and it stands for 10 power minus 18. Okay, minus 18 is the prefix used for atto. Okay, coming towards MCQs number 6. Which of the following numbers shows one significant digit? 4 options are given over here. Option number D. Option number D or last option is the correct option. 6 multiplied by 10 power 2 is the right option. Okay, come to MCQs number 7. Which of the following numbers shows 4 significant digits? Okay, right option over here is option number A, that is 900.8. This is the number which shows 4 significant digit. Okay, now coming back towards question number MCQs number 8. What does it says? Okay, a light year is a distance traveled by light in 1 year. It travels about 9.460 into 10 raised to the power 15 meters. How many significant figures are in this number? Okay, in the given number there are 4 significant figures or 4 significant digits. So right option is D option. MCQs 8's right option is D. 4 is the right option over here, which is option number D. Okay, coming towards MCQs 9, it says 0.2 millimeter in units of meters is. Okay, 4 options are given over here. Option A and option B both are correct, right? So C is none over here and D is both A and B. So last option MCQs 9, last option D is correct, which is both A and B. Okay, coming towards last MCQs, it says Kitab al-Manazir is the name of book written by which scientist? Okay, so no doubt that is Ibn al-Haytham, option number B. MCQs 10, option number B is the right option, which is Ibn al-Haytham. Okay, so this was all about MCQs. Okay, now we are going to discuss conceptual questions of chapter number 1, class 9 physics, physical quantities and measurements. Okay, now look, what is the first conceptual question? What does it says? In the first conceptual question, it says how technology is shaped by physics. The first question is how technology is shaped by physics. You know, physics is actually backbone of the sciences, all the sciences. You know, it discusses with matter, space and their energy. You know, in physics there are different fruits of physics. You know, physics enables us in medical sector to understand the things better. It enables us to do the new to introduce new things in the defense, and it also enables us to introduce new things in medical sector, defense sector, agriculture sector and all the other things. It enables us to understand the nature. You know, nowadays in medical technology, if you see, you use different kind of medical instruments like CT scan, MRI and X-rays, ultrasound. All these are what? These are fruits of physics already given by physics, because they are working on the rules of physics and principles of physics. So in medical sector there are a lot of applications of physics. There are a lot of things which on which physics works. Okay, and there are defense purposes. You know, in defense you see different drones and different things over there. So all these are what? They are working on principles of physics. Okay, nowadays you see mobile technology, information and communication technology, all this are working on the rules of physics. You know, mobile phone is one of the best thing which works on physics, principal physics technology, computer and all the things over there, they are working on the rules of physics. So this was all about how technology is shaped by physics. There are a lot, but I'm discussing few. Okay. Now coming towards conceptual question number 2. What does it says? It says physics and biology are different branches of sciences. How physics is linked with biology? You know, physics, we already have discussed, physics is the study of nature, like it discusses matter, energy and their mutual relationship, while biology is the study of living organisms. Okay. You know, if we have no matter, no space and no energy, how can we study living organism? No. Okay. So physics provide a gateway to the biology, right? It provides the gateway to the biology. Like in biology we discuss the things on behalf of physics rules and principles. There are a lot of the things on which physics rules are applicable, and it is worked and it is used in actually biology. So physics is quite related to biology. Okay. Why let's come towards third conceptual question. Why are measurements important? Okay. Why we discuss measurements and why it is important in our daily life. You know, in measurement, what is measurement? The comparison of an unknown quantity with a certain known quantity is known as measurements. Okay. Now in measurement we discuss magnitude, like a number along with the proper unit. Like if there were no measurement, how can we understand the things? Like if you go to a shop and you buy something, or there, for example, you buy a sugar from there, for example 5 kilogram sugar. So if you don't say 5 kilograms, so how can the shopkeeper will understand that what you are asking for? So measurement is quite easy and very important in physics, because it enables us to understand the things in a more better way. We find the length, width, we analyze different quantities on behalf of their magnitude, on behalf of their measurement. If there is no measurement, how can we understand different things? Okay, so this was how measurements are important. Now coming towards conceptual question number 4. It says why area is a derived physical quantity. Okay, why area is a derived physical quantity? You know, we have defined derived physical quantity as all those quantities which are derived from base physical quantities, known as derived physical quantities. You know, we have already discussed it over there. Like all those quantities to define which base quantities are needed are known as what? Derived physical quantities. Area is derived physical quantity because it is obtained as a result of multiplication of two base quantities, that is length. Like if you multiply length into length, it will give you area. Okay, so this was so we can say that to define area, length is needed. That is why we say that area is a derived physical quantity. Okay, now coming towards conceptual question number 5. It says name any 4 derived units and write them in their base units. Let's discuss. First is area. We know that length into width, area is equal to. So length is also measured in the units of meter, width is also measured in the units of meter, and it will be meter square. Okay, now coming towards density. Density, we know that it's equal to mass per unit volume. So we say m by v. M will be as it is. M shows you mass and volume shows you length into width into height. Okay, mass is represented in units of kilograms, and length, width, height is the units are meter cube. Okay, we shift this m power 3 over there, so we will get kilogram m power minus 3. Okay, coming towards acceleration. Now we know that acceleration is equal to change in velocity divided by time. The unit for change in velocity we write meters per second over there. Like velocity unit is meter per second and time is second. So we shift this s upward and we get m/s power 2. Okay, so this was conceptual question number 5. Now we are coming towards conceptual question number 6. Okay, now we are going to discuss conceptual question number 6. What does it say in conceptual question number 6? Let me read the statement. It says, why in physics we need to write a number in scientific notation? You know, to find out the number, like if what is scientific notation? Like the scientific notation is the notation in which we write a very large number or a very small number in very easily. like it helps us to write a very large number or a very small number in easy way. It saves our time and make our calculation easy. So we need to find our all result, like whatever final result we are going to obtain in a certain experiment. So we have to show it in scientific notation. So because it is easy to understand, easy to calculate, easy to find out significant figures in that, and all the things over there. Done ho gaya? Okay, we are going to now discuss conceptual question number 7. What does it say? Let me read the statement. It says, what is least count and how the least count of vernier calipers and screw gauge is measured? Least count, the general definition of least count is the minimum measurement that we can take through a certain device is known as least count of that device. For screw gauge and vernier calipers, there are two different definitions. Look. For vernier calipers, we say smallest division on main scale divided by number of divisions on vernier scale. Okay, now smallest division on main scale is 1 millimeter and number of divisions on vernier scale are 10. So when you divide it, you are going to get 0.1 millimeter or 0.01 centimeter. This was for vernier calipers. Now coming towards screw gauge. What is screw gauge least count? Screw gauge least count can be defined as pitch of the screw gauge divided by total number of divisions on circular scale. There are two type of screw gauge, one with 50 number of division, one with 100 number of divisions. For both least count are same. Look, pitch of the screw for 50 division containing screw gauge is 0.5 millimeter divided by 50. Okay, if you are using a screw gauge with 100 divisions, so pitch will be 1 millimeter over there and divided by 100. So when you are going to divide it, you are going to get 0.01 millimeter or 0.001 centimeters. Okay, coming towards last conceptual question. What does it say? Let me read the statement. How can we find the volume of a small pebble by using measuring cylinder? Okay, we know that measuring cylinder was a kind of a vertical column, and what we do to find out the volume of a pebble, first of all, fill any liquid or water into the measuring cylinder. Note the initial volume, that is V1. After that, put a kind of a solid body or any body into it. The water surface will raise, and what we do, find the final volume over there. Okay, now to find out the volume of pebble, what we do, we write change in volume, like del V is equal to V2 minus V1. This V2 is final volume, this V1 is initial volume. Okay, so we subtract it and you get the volume of a pebble over there. So this was all about today's lecture. We have let me summarize the thing. In today's lecture we have discussed MCQs of chapter number 1. Also conceptual questions of chapter number 1, physical quantities and measurements, right? Chapter 1 is finished. Okay, we have discussed all the MCQs with their right options, with their exact values over there, with their solution manuals, like how they are solved. Solution manual is quite important in understanding the MCQs. Okay, so this is how we do with it. Okay, and in conceptual question we have discussed 8 conceptual questions, each with statement, each with justifications, each with examples. So this was all about today's lecture. Hope you have enjoyed the lecture. Thanks for watching. Allah Hafiz. Fi aman Allah.